Okay, here we are on our next Wireshark lab, the TCP and UDP part. And I'm not going to do every single step, but I'm going to try to show you some of the things that most students get hung up on. So the first thing we're going to do is capture a UDP datagram so that we can take a look at it. So let's make sure that we are running. And we'll go ahead and do a NS lookup of some website. And we can see now that that generated a DNS request, which is a UDP packet. If you highlight any one of those, a DNS request, you can see that it is using user datagram protocol, and you can answer the appropriate questions on the assignment looking at that user datagram protocol packet. The second part of the assignment is doing some TCP stuff. So if I come back and start capturing again, you're supposed to download a file and then upload it back up. So I've already downloaded it. I'm going to upload it again, this alice.txt file, and I'm going to upload it. And we will see back over here in Wireshark that it is indeed uploading it. And we can actually wait for a minute if we want to see if we can capture that fin segment as it goes along. And there it went, the fin and FINAC. Now my network, I'm doing it on my home network, so there's not a lot of traffic. If you're doing it at school, you're going to see a much more traffic going on here. So now what you need to do is you need to answer some different questions. So let's take a look. What's the relative sequence number of the TCP SYN segment that's used to initiate the connection? So if we look up here, let's take a look at, we don't care about this raw data. Let's just take a look at our TCP. And if we look at our sequence number, notice the relative sequence number there. Exciting. So now, which field in the TCP header identifies the segment as a SYN segment? And if you look down here, well, I'm not on the SYN segment, there it is. SYN segment, if you look here at the flags, you can go find that. Take a look at that. So you can look there and look for the sequence number. What's the relative sequence number of the SYNAC segment sent by the server as an acknowledgement? Well, here's the SYNAC. Let's take a look at the, it's showing this sequence number, but really this is one we're looking at. We've acknowledged that we received that first byte of data from the server or from the client. So there's some where we can answer the questions for that. What is the relative sequence number of the TCP segment containing the HTTP post command? We need to find where post appears in the raw packet data. So in this case, it's after we have done this. Now you can look about right there, post, that's where that occurs. So what's the relative sequence number there? Now we come back up here and look at the relative sequence number 530, meaning I've received up and through byte 530. List the segment numbers of the first 6 segments transmitted from your machine to the server, starting with the segment containing the post request. Okay, so there's the post request sent by my machine there. Let's look at the next one sent by my machine. Relative sequence number 1990. Next one, 3450. Yours aren't going to be the same, or I would doubt they'll be the same. So you're going to look for a couple of those. First 6 segments. What is the length of each of those same 6 segments? Specifically, what is the length of the application layer data? So if we look at the application layer data, we can, if I expand this a little bit, let's look at, yeah. Okay, so now, how are we going to figure out what our size of our application layer data is? Well, once again, 14 bytes on the wire. Take away all your header information, and that will tell you how much of your application layer data is there. And I believe that we can. Sometimes you have to make sure the HTTP protocol is enabled so that you're seeing it. And so you come over to this location and you make sure that it is checked, and mine's checked, so we're okay. Anyway, what's the overall throughput for the TCP connection for the first 100 kilobytes? Well, we start up here. We can basically start with our SYN, that's fine. And from our SYN segment then, we can mark the time at 4.101. We can mark our ending time, so if we look at these ACKs, I'm trying to find where this number has acknowledged up through byte 100,000, and so we're kind of come down here until we've got down to about byte 100,000, and at that point, about right there, we'd record that number, we'd subtract the end time from the start time, and we would be able to calculate the approximate throughput.